In this video, we'll be taking a look at some of the key concepts of utility network management for ArcGIS, Esri's long-term GIS solution for network management for a modern utility. In this presentation, we'll look at some of the drivers for adopting the technology and an overview of key concepts and capabilities. My name is Megan Cheong, and I'm part of the Technical Solutions team based in Wellington. And we also have...
I'm Aaron Sapsford, GIS Utilities Practice Lead at Eagle Technology based in Wellington. Conceptually, ArcGIS is a system of systems comprising of a system of record, and this is your traditional relational database with an additional tier of management enabling the enterprise geodatabase functionality. This supports and extends capabilities for geometries, business rules, topologies, and versioned edit workflows as your authoritative data source. A system of engagement is your spatial portal where your context is secured, published, and shared in a variety of ways using out-of-the-box or customized templates, maps, and applications. Your system of insights supports and improves the user experience through the consumption, collection, and analysis of data from the combined sources of your system of record and your system of engagement. Esri provides apps that support insight like Ops Dashboard and Insights for ArcGIS. Your system of design takes digital work packages and seamlessly transfers them within the enterprise for your entire network lifecycle, from design to construction to as-building and commissioning and map correction. So what ties all of these systems together for a utility? Utility network management for ArcGIS is the foundational technology based on ArcGIS Enterprise. It's designed to meet the evolving needs of utilities as well as the communities and organisations they serve. Utility-specific GIS tools offer diagramming, mapping, and modelling capabilities to track and maintain assets, sensors, pipes and cables, as well as managing data on Esri's enterprise platform that meets all of your data needs and compliance standards. Digital transformation can mean different things, but it's driven by disruptive technology and disruptive events. Utilities are increasingly seeing a need for a more connected workforce with access to real-time data being supplied from various sources. Everything happens somewhere, and ArcGIS delivers a technology platform to ensure that everyone can access location information on any device, any place, at any time. Utilities today are more than ever needing to leverage web GIS capabilities. For instance, if you look at any local council website, most will have a public-facing web map of some sort. Many have their water network or the locations of planned works published. Some may even publish the location of current outages with a time to restoration, or allowing the public to log faults and incidents in a web mapping application for operations centres to respond to. Field crews in all sectors are increasingly required to inspect, capture or update asset data in the field using mobile devices. The utility network not only satisfies the needs of the back office in the traditional sense for creating maps, inputting and updating your GIS data and other analytics and reporting requirements, but it also brings all of the web GIS capabilities to the fore by enabling utility-centric concepts and workflows to a modern GIS pattern for the whole organisation. The utility network enables these capabilities that fully align with web GIS patterns of use. Utility network management enables real-time sharing and collaboration across your organisation. To take advantage of this, ArcGIS as a platform enables capabilities via the utility network framework. These capabilities are then leveraged through solutions. This extends the reach of your GIS from the back office right out into the field so everyone has a near real-time view of what's going on. Desktop GIS will always be the place to maintain data through your editing tools. ArcGIS Pro is the primary connected desktop environment where users interact with the network for map authoring, data editing with design and versioning, sub-network management, 2D and 3D views with diagrams, and rich analytics including tracing. So all this means a shift of your traditional GIS workflows from ArcMap to ArcGIS Pro. Access to your network data is via the Enterprise portal. So focused web applications can be used for viewing, querying and updating information. Through your Enterprise portal, shared maps, apps and dashboards expose your tracing experiences in the web, and it's now accessed directly via the network service in a widget. so users don't have to be well versed in complex desktop applications to now take advantage of advanced capabilities such as tracing. The network can also be accessed on mobile applications for iOS, Android and Windows, whether it's out-of-the-box apps like Collector and Survey123, or several focused partner web, mobile and runtime applications built on SDKs, all supporting mobile mapping, network design, inspection workflows, redlining or field markup, mobile tracing, and it's all supported in either a disconnected or connected state. So that's probably enough talking from me. So what does the utility network look like in action? So I'll hand over to Megan now for a quick walkthrough and demonstration.
I have here some electrical network data opened up in ArcGIS Pro. This data is from Network Waitaki, an electrical distributor based in North Otago, in the South Island of New Zealand. I'll be demoing to you what the data model looks like, some editing capabilities, tracing and diagrams, as well as showing the utility network in a web app and in 3D. In the Contents pane, you can see I'm accessing the utility network from a file geodatabase, which was made possible since the ArcGIS Pro 2.5 update. If we take a look on the left, you'll see that the domain-specific features are split into only 5 feature classes: devices, junctions, lines, assemblies, and the subnet line. However, if you expand one of the feature classes, you'll see each split into asset groups, which are the general categorizations or descriptions, such as low voltage arresters. Each asset group is further defined into asset types, which are more specific. The great thing about asset types is you can toggle labeling on and off, set scale dependencies, and symbology for each type. Therefore, they behave like individual layers, although they are all coming from the one feature class in the back end. So where before in a geometric network there may be 30 to 40 different feature layers for each asset type, the utility network allows you to have far fewer, with the advantage being faster analytics and queries, as well as faster visualization when panning and zooming the map. One of the key modeling capabilities of the utility network are containments and associations, which allow your network to be modeled to a high degree of detail. Here is an electrical cabinet, and within it we can see a transformer bank linking to a high voltage line, as well as some low voltage lines leading into the cabinet. With the idea of containment, we can go to the utility network ribbon and enter containment mode to go inside this electrical cabinet and actually view the assets contained within, such as these connection points and network protectors. This capability declutters your map, keeping it clean, but still allowing you to model your assets accurately. You may be wondering how the features within are connected to one another. This is where connectivity associations can help. If I turn on View Associations, we see these dashed lines appear, which represent the implicit connectivity. Connectivity associations allow you to model relationships between points that aren't necessarily coincident in real life, and adding associations is as simple as opening the Modify Associations pane and selecting the features you want to associate. So the utility network lets you take advantage of associations because associated features can participate in traces and analytics. I'll switch over now to an overhead transformer to show you some examples of structural attachments, which are another type of association. Here is a pole and a transformer bank with some other features surrounding it. If I switch on View Associations, we can see these surrounding features are associated with the transformer, but notice the green dashed lines. These represent structural attachment associations, and they help model how the various connection points and transformer bank are attached to the pole. What is great about structural attachments is that once you want to move the pole, all associated attachments will move as well, making it not only easier to model how your assets accurately relate to one another, but also makes editing that much simpler and straightforward. Another great feature of the utility network is a rule-based topology to ensure better quality data goes in. Put simply, this just means that if a rule doesn't exist for features to connect, it cannot happen. To add new features, the utility network takes full advantage of group editing templates. I'll add a simple overhead service drop to this house here. Normally, you would need separate features for the attachment point, overhead conductor line, and service connection. But with group editing templates, I can add all of this in a single editing action. When I hover over the connection point, you'll see my cursor turn into a snapping tip, indicating that there's a network rule set up in my topology allowing me to connect these features and assuring me that my edits are appropriate. So I can click once to add my attachment point, and then double-click to drop my service connection. After adding the feature, we'll see this purple polygon. This represents a dirty area, telling us that the edit is not yet incorporated into the network topology. In order to clean up these dirty areas, you simply have to validate the network topology. After which, the edit will be able to participate in the network and be included when running traces. And as you can tell, the utility network's rule-based topology prevents the entry of invalid data and helps to maintain higher quality data in your network. The utility network supports advanced tracing analytics to help you derive more information from your network than ever before. Let's say you want to know how many customers there are in your subnetwork, or you want to determine which customers are still connected after a major weather event. Tracing enables you to find these answers. I'll show you a quick example here of an upstream trace. I'll add a starting point at the service connection that I just created. Then I will fill out some parameters in the trace geoprocessing tool, such as which domain the trace will run in, which is electric. I'll choose electric distribution for both the tier and the target tier because that's where the data is situated. But note that traces can run across tiers. The upstream trace executes, and it will show us all the features located upstream from the starting point. So now we know the source of this subnetwork, which in this case is a circuit breaker in the substation, and we can confirm that the newly added residential service drop has established a flow from the substation. Although a map-centric view of the utility network is great to work with, sometimes you want to obtain a more logical view of the network. This is where network diagrams come into play. To create one, I can simply select the subset of my network that I want and click a button. The utility network includes pre-configured schematic diagramming capabilities that allow the generation of diagrams without any setup. There are a number of different layouts to choose from as well to suit your business needs, such as the smart tree layout. Diagrams allow side-by-side viewing and interaction with the map. For instance, if I select a feature in the diagram, the selection can be propagated across into the map, allowing me to see where the feature is located geographically. Furthermore, you can store diagrams as well. This is a useful tool for users such as engineers who can easily generate and view multi-level representations and check network connectivity. Like Aaron mentioned, the utility network enables real-time sharing and is a platform for collaboration across an organization. Once the utility network is published, you can deploy the electric network viewer to visualize your utility network service in a web app, allowing users to see where their organization's assets are in the field and eliminating the need for paper maps. For instance, field staff who need to conduct maintenance on certain assets can search for the asset in the app and know right away the asset's status, location, and other information with the confidence that they are viewing the most up-to-date information. With the web app, you can also configure analytical widgets, like running a trace. Here you can select the starting point, in this case the service point, and then run a subnetwork trace to find all that are in the subnetwork. And you can view additional useful information such as see the number of customers, the length of lines, etc. Due to the web map's intuitive interface, users don't have to be ArcGIS Pro experts to take advantage of tracing capabilities and querying information. Lastly, the utility network is 3D enabled. Here's a scene of Oamaru showing Network Waitaki's lines and poles. We work with the Esri 3D Solutions team and GeoCam to create these procedural models of the utility network in these scenes, set on a 3D mesh captured using drone and aerial cameras. 3D scenes provide the platform for more advanced analysis like line swing analysis and vegetation encroachment. As I hope you can tell, the utility network provides a comprehensive solution for enabling utilities, and here at Eagle, we are pleased to bring this technology to our clients in New Zealand. Let's go back to Aaron now, who will explain about the utility network's conceptual architecture.
Thanks, Megan. That has highlighted some of the core functionality of utility network management for ArcGIS, but has really only just scratched the surface. So I'd just like to take a minute or two now to talk about some of the moving parts of a utility network behind the scenes. Firstly, you'll need an enterprise-based deployment. What this looks like may differ slightly depending on your organisation's IT infrastructure requirements, but essentially ArcGIS Enterprise is your engine room. Next, and most probably crucially, is the utility network configuration for your industry domain. This includes all of your feature geometries, supporting tables, business attributes, and rules based on your organisation's requirements. And this is what will enable your GIS to behave like a real network. This is all contained inside of an asset package. Now, an asset package is a special flavour of file geodatabase that I'll be explaining in a little more detail in an upcoming presentation. You will need an enterprise geodatabase. This doesn't change. The enterprise geodatabase still remains your system of record. All of your features, tables, business attributes, domains, and topology rules will all live inside the geodatabase. Once your data is ready to go, the utility network services are then published to your enterprise portal. These services are what allows your users and integrations to communicate and interact with your network data. These services are used to view and query your data, validate your network topology, perform traces, manage editors' versions with the new branch versioning framework, and the ability to generate and store network schematic diagrams. There's a lot of information on each of these touch points, but we'll expand on these a little further in our upcoming videos. Esri has produced some pretty comprehensive documentation and content if you want to get started. There are some industry-specific solution templates available to download from solutions.arcgis.com. These solution templates are your foundation or starting point that comes with sample data to get you hands-on quickly to do some discovery and evaluation. If your company is looking to upskill or transition to ArcGIS Pro, there's also a recommended training pathway to get your users up to speed with the tools they need to start working with the utility network. Also, Eagle can work with you and help your organisation to assess your data readiness, pilot a subset of your data in a utility network, and then prepare you for a full migration. You can contact us here at Eagle if you want to know more. Also, coming up will be some more video content on utility network for ArcGIS.
Before we wrap up, here are a few common questions that have been asked by our user community. What additional licensing is needed for the utility network?
If you already have an enterprise license agreement, you may already be entitled to the licensing you need. So it's probably best to contact your account manager to check before you get started. If we have ArcFM already, what happens to it if we move to the utility network?
ArcFM doesn't go away. Schneider Electric has their ArcFM Solution 11 built on ArcGIS Pro. It differs somewhat from the ArcFM Classic extension built on ArcMap. It delivers utility-specific productivity, editing, and validation tools to extend ArcGIS Pro. There are some pretty cool enhanced utility trace tasks and session management for your edit versions. ArcFM is a solution that's built on the utility network framework with industry-specific tools and workflows that extend the core utility network capabilities. Feel free to reach out to us if you want to know more or see ArcFM in action. How are electric feeder IDs propagated?
Feeder IDs are created at the subnetwork level, so a device acting as a subnetwork controller or source is given a unique name like a feeder ID. All of your assets that are physically and logically connected to that same subpart of the network then inherit the subnetwork name. Similarly, in a water or gas network, this might be like an isolation zone that's controlled by multiple isolation valves that share the same subnetwork name. Can you trace on different electric phases?
Yes, you can. By adding a filter in the Trace tool, you're able to add a query that will only return features that are energized on a specific phase, or any combination of phasing you like. The tracing analytics allow you to build your own custom trace task for any use case, and that's not just restricted to electric tracing. A wide variety of trace scenarios for electric, water, gas, and telco networks are able to be built, run, and rerun using the out-of-the-box trace task as your foundation. How can we access a utility network for evaluation? Is there a demo service?
That's a great question. We don't have an open demo site ready just yet, but if you want to get started quickly and you have ArcGIS Pro 2.5 standard, you can download a foundation solution template from the ArcGIS Solutions page and stand up a utility network in a file geodatabase for a single user. Because it's not the full-blown services-based solution, you won't be able to test web or mobile or integrations with other systems, but it will allow you to try out basic functions like editing, tracing, and diagrams, and to explore the data model and get up to speed quickly. Stay tuned for upcoming video presentations on utility network management for ArcGIS. We'll cover topics such as network concepts, planning your migration, and the utility network in action with some really cool demonstrations.
For any more information or questions about the content covered in this presentation, please contact us here at Eagle at the email address on screen, utilities@eagle.co.nz.